We can't factor it, so you could complete the square, but it wouldn't make sense to complete the square. If you did, awesome on you, but in what I'm thinking about is to complete the square, I'd have to divide everything by 5. And my b value would be 4 over 5, and I'd 3 over 4 on the other side, and I'd have to do 4 over 5 divided by 1/2, square that. I'm looking at that, and that's going to be just a lot of extra work. So this is probably one that I don't want to complete the square. Usually what tells you to complete the square is if you just have a 1 here, or if they're all going to just be whole numbers is usually a good complete square. So that's not going to quite work. So let's use the quadratic formula, which would be negative b, so that would be negative 4 plus or minus the square root of 4 squared minus 4 times a times c, which would be 4 times 5 times 3, all over 2 times a, which would be 2 times 5. Working this through, we'd come up with negative 4 plus or minus the square root of negative 44. And I picked this one out for a reason. There were several people in the homework that said, at this next step, they said it's an imaginary number, so I don't need to go any further. You do have to come up with your imaginary number on the test. All right? And so what I'm looking at is I'm really thinking this is I times the square root of 44, which we can reduce down to I to square root of 11. So rewriting this, I'd have negative 4 plus or minus 2, I usually put the I in front, square root of 11 over 10. And we really do have two fractions there. We have negative 4 over 10 plus or minus 2 over 10. Well, all those reduce kind of the same way. 2 goes into everything in the numerator and everything in the denominator. So negative 4 divided by 2 would be negative 2. Plus or minus 2 divided by 2 is 1, so we just have I square root of 11 all over 5. That is our final answer. Know how to do that.
Oh, I got it right.
Nice. Make sure you know it for Thursday, because you want to get anything I asked basically to use a quadratic formula to come up with a real or imaginary number, so those should be really, really quick ones. If I tell you to complete the square, maybe we're a bit sluggish on that one because we haven't done it as much, but anytime I say you can use the quadratic formula, it should be just a really easy plug and chug type situation. All right, any questions on that? All right, as I said, test is on Thursday. You do have the review sheet already. It's always a good idea to start as soon as possible, because Wednesday I'm going to check at the end of class how far you are once again. I'm 99% sure we aren't going to do test corrections on this one. So the only people that are going to be eligible to do anything are people that fail the test. And you'll only be eligible to retake the test and only get an 80 on it. All right? So make sure you really study for this test so you don't have to worry about it over break. Because if you do bad on it, you have to retake the test. I'm going to make you take it really quick after we come back so you don't fall behind. All right, so test Thursday. Make sure you study. Make sure you work on that review packet as best you can. That being said, today is going to be really dry, quick, boring kind of stuff, just because this is all stuff you were supposed to know. So I'm just kind of flying through a ton of material all at once. So please stop me if you don't know what I'm talking about. So the first thing we have to start with is interval notation. That is just a series of a whole bunch of numbers. So if we look over there, I have 0 to 20. As written, it has square brackets 0 to 20. So what that statement is saying right now, as written, it is saying all of the numbers from 0 to 20, decimals included, including 0 and 20, because square brackets mean include those two numbers. If I rewrote this, it wouldn't change all that much. So I'm going to go ahead and rewrite this really quick with magic. Make those two things disappear, and I'm going to put parentheses on there. Now it says almost the same information. It says it's still from 0 to 20, but this time it says do not include 0, do not include 20. All right? So the parentheses mean do not include those two numbers. Our brackets, our square brackets, mean include. Now I'm going to say two more new words with this that you should have heard of before. Parentheses are what we call open. It is an open system if it has parentheses. And why it's called open is because, does that include 0 if I have parentheses? No. It doesn't include 0 because parentheses mean it doesn't include. It includes the very next number that's bigger than 0. Can someone name the smallest number that's right next to 0? That's still positive. No one should be able to name that because it's 0, infinite number of zeros, and then a 1 once you reach infinity. If you could write that out, you'd be a bazillionaire if you could figure out what infinity meant. So that's why it's open, because you actually don't know where it starts. I couldn't say, hey, Patrick, tell me that first number that appears here. You're going to be like, no. Or what's the last number that appears? You're going to say, no. It's open. It's open. We don't know what the beginning and end is. However, if I bring back those brackets, it is now closed. Now if I say, Ahmed, your entire grade is based upon the fact that you tell me what's the very first number in this system. 0. It's closed. It's stuck. It's 0. There's no interpretation to it. And the very last number is 20. That's why it's called closed. Do not spend a whole bunch of time memorizing open and closed. It's not going to be in the test, but it is interesting, and it has to do with interval notation. And that's why we have it starting off. So the first thing we're going to talk about is unbounded intervals. We're talking about intervals. Unbounded intervals are just intervals that have the infinity symbol somewhere in it. So if we look at all of our different sets in that left-hand column, we have x is bigger than a, x is smaller than a. Note that neither one of those have an equal to sign. That is why in interval notation, we use parentheses. No equal sign means you're going to use parentheses. The next two sets are x is greater than or equal to a and x is less than or equal to a. These use brackets because they have equal signs. An equal sign lets you know you're using a bracket. And finally, we have the basically negative infinity to infinity. That's obviously going to have parentheses because no one knows where infinity starts and no one knows where it ends. Then I said what type they were. They're open if they just have parentheses. They're closed if they have that bracket. And it's okay they have a parenthesis at the end through infinity because infinity always does. You still say it's closed. You still say it's closed. If I ask you to graph these, I'm not looking for a whole bunch of great number lines out there. This is all I'm asking you to do. And in fact, let's come up with our example first and then graph that example. So let's say x is bigger than 3. That matches our x is bigger than a. You're just going to come up with a number line, and you're just going to put a big old 3 on there. You can, if you want to, you can put a 4 on -2, or not a -2, a +2. You don't have to do that. Right is always positive, left is always negative, unless you put otherwise. So x is greater than 3 would be, I'm going to put a parenthesis, and I'm going to put a little squiggly coloring in this. Now, there are many ways to do this. This is not the only way. This is just the way that I do it. The other way you can do it is you can do an open dot and fill it in. And some people even write above it, and they just put it like an arrow. I always just put a parenthesis, and I scribble, because the higher up you get in math, the more likely you're to use the symbols that were given to you. So I just go ahead and use a parenthesis. All right, our next one, let's do an example. Let's do x is less than -2. Let's do x is -2. So this is the bare bones minimum on a test. If I ask you to graph x is less than -2, this is all you have to do, -2. It's less than, there's no equal to sign, so I'll put a parenthesis, and I fill in that side. That's all you need to do. If you have more room, you might want to make sure that negative isn't buried kind of in it. So I can see it's -2, but that works. Our next one would be x is greater than or equal to. So maybe an example would be x is, let's do that back about. X is greater than or equal to 4. So let's go here. Let's say 4 is right here. Doesn't matter where I put it. Since it's greater than or equal to, this time I'm going to use a bracket. And I'm going to fill it in. The other way you can do it is you can do a closed dot if you wanted to. Just make sure you fill in the dot to say it includes that point. I am just going to stick with my bracket. Bracket fill in. All right, maybe we'll do x is less than or equal to, I don't know, 100. Even though it's a big number, it's still just as easy to graph. We're just going to put 100 right here. It is less than or equal to, so I'll put a bracket, and I scribble some stuff in. Not anything mind-blowing. The last thing is probably the most unique one. We're looking for a solution set that's negative infinity to infinity. Now, using linear inequalities, I'm just going to say x is less than or equal to x. That is just a true statement. X is always less than or equal to x, because 3 is less than or equal to 3, 4 is less than or equal to 4, negative 100 is less than or equal to negative 100. And to graph this, to graph something that has infinite solutions, you're just going to color in the whole line. And that is unbounded intervals. On the bottom it says write the inequalities that correspond to the given intervals. So our first one is negative infinity to negative 9. The easiest way to write it is just ask yourself, what is it saying? Well, there's no equal to sign because we don't have a square bracket, so we're going to either use a less than or a greater than sign. And I'm looking for numbers that are smaller than negative 9. So just thinking in plain English, x has to be numbers smaller than negative 9, so x must be less than negative 9. And so that'd be like negative 10, negative 11, negative 12. Yeah, that fits that interval. All right, next one we do have a bracket. So that means I must have either a greater than or equal to or a less than or equal to. So I'm looking at it, and it says it goes from 0 to infinity. So I'm looking for numbers bigger than 0. So in order for that to happen, x has to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Continue. So x must be bigger than or equal to 0. That's the only way I'm going to have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or some kind of thing that's bigger than 0. All right, any questions on unbounded? All right, then let's get to bounded. Since unbounded is we use the infinity symbol, bounded is we don't use the infinity symbol. We have bounds on the left-hand side and the right-hand side. That's why it's called bounded. I have a left start point and I have a right end point. So we have 3 examples there. The first one is a is less than x is less than b. Well, that's really saying x needs to be bigger than a and x has to be less than b. Since there's no equal to signs, we use parentheses on both sides, which means it is open. A graph, an arbitrary graph of this would be something like this. Since a must be smaller than b based upon where it's put, we'll put a first. We'll put b second. Since we're using parentheses, let's use parentheses here as well and just color in the in-between area. X is somewhere between a and b. Our next one's almost identical. X is still between a and b. However, this time we have equal signs. So rather than using parentheses, we are going to use brackets. So we can set up the same situation where we have a and b. However, this time I'm going to use brackets, which makes it a closed system. We shade it in. All right, our book, and that's why the words are right there. Our book says if one of them's open and one of them's closed, we're going to call it half open. My preference on labeling this one is I usually just say it's neither. Because the question is usually, is it open or is it closed? And in fact, there's kind of a snarky name for this. It's called clopen, which means it's not closed, it's not open, it is clopen. But it's kind of a snarky thing because you're really supposed to think of it as either being open or closed or neither. So our book says half open. You can use clopen, you can use neither. I'm not too concerned about what you call it. Just make sure you're able to graph what's happening. And that is, once again, we're somewhere between A and B. However, this time we have an equal sign that matches up with the A and no equal sign that matches up with the B. So on the A side, we should have a bracket. On the B side, we should have a parenthesis, and we connect it like that. And obviously, B could be closed and A could be open. All right, so that is bounded and unbounded intervals. The next thing we're going to jump to is linear inequalities, which is just the same thing as a linear equation that we've been dealing with one big change. We are no longer going to have an equal sign. We're going to have a greater than, a greater than or equal to, a less than or equal to sign. That's what's going to change it. And it really isn't going to change how we solve it. We are still going to solve for x by moving x to one side and a number to the other side. The only big difference we have to keep aware of is when we are solving it, if we ever multiply or divide by a negative number, you need to flip your sign. And in fact, without you knowing it, even when it's an equal sign, it really does flip, but you can't really see it with an equal sign. So it is always flipping. Big thing. Changes your whole answer. So anytime you multiply or divide by a negative number, you need to flip it. Now pay attention here because people make this mistake. If you add a negative to both sides, it doesn't do anything. If I multiply by a whole number, say I multiply both sides by 2, it does not flip it. It has to meet both those criteria. I have to be multiplying or dividing a negative number. So every negative number doesn't make it flip. It's just when you're multiplying or dividing by it. And that's what's going to happen in this first one. So we're going to solve this kind of like a normal equation. We're going to add 9 to both sides to get the x's on one side, all the numbers on the other side, which is going to give me negative 3x is less than 9. However, here is where we're going to have to flip stuff because I am dividing by a negative number. So something should jump in your head that says we are dividing by a negative number. Something should just jump in your head and say, hey, that causes something to happen. So yeah, our negative 3 divided by negative 3 is a positive x, but we need to flip that sign to become greater than a negative 3. Now here's what happens if you're one of those people that kind of don't read each question carefully. I did not answer the question. I did, in sorts, but when I go back up here and I carefully read it, it says solve and write the solution set in interval notation. I didn't write an interval notation, so I'm going to lose points if I don't do it. So make sure you read each question very carefully. In fact, I'll never take off points if you write everything in interval notation, but I will take off points if you don't write an interval notation and I ask you to. So the interval notation of this would be, I'm looking for all numbers that are bigger than negative 3. So the farthest left I'm going to go is negative 3. And I want all those numbers that are bigger than that, so that would be infinity. So those say the same thing, it's just this is interval notation. But both those statements say the same thing. All right, the next one has fractions. But for those that hate fractions, you shouldn't be that upset because your first step is just get rid of fractions. If you don't like fractions, just get rid of them. So we need to multiply by a lowest common denominator, in which case you could use 8 because 2 times 4 is 8. 8 would work, but a better one would be just multiplying by 4. Because when I distribute this to the 1/2, we're going to have 2x. When I distribute this to the negative 3, I'm going to have negative 12. When I distribute this to 1/4, I'm just going to have is greater than or equal to just x. And finally, I distribute it to the 2, which gives me 8. Let's subtract x from both sides. That will give me x minus 12 is greater than or equal to 8. Add 12 to both sides, and we're going to have x is greater than or equal to 20. Once again, I didn't complete this yet. I do have to write it in interval notation. X needs to be bigger than 20, so I'm talking 20, 21, 22, 23, 24. So 20 must be the smallest one. It is going to be a bracket because there is an equal sign, and it's going to go to infinity. So careful when you read those. They're not hard to do, but they're hard if you don't read the question and you don't do it, and then you get your test back and you lose 4 points because you didn't read the directions. You're like, ugh, that was the difference between an A and a B. Ooh, I should put a parenthesis around infinity. All right, those are linear inequalities. If I remember last year we did pretty well on that part. Where we got kind of messed up was compound inequalities. And it more or less just stems from not knowing which ones applied to where. So we have compound inequalities. A compound inequality is just basically two inequalities that are connected with either the word and or. And the first compound inequality we're going to talk about is something called intersection. An intersection, and when I think about intersection, I think about roads. I think about roads intersecting. Now, when I ask you about intersecting roads, like if I say Lisbon and Capitol, you're just looking at that corner, right, where those two streets overlap. That is an intersection. I'm not going to look at the entire street of Lisbon and the entire Capitol and say it's all of Lisbon and all of Capitol. It's just that one little spot where they intersect. The same thing applies with sets. Intersection is just what both sets have in common. What is their overlap? What is their overlap? So if I said someone that's blonde, let's just do it this way. All right, the symbol for this is an upside down U, like an N. Kind of like a lowercase n kind of thing. But it's just an upside down U. And that upside down U in math, that stands for and. And that's why the next statement says A upside down U, B is read A and B. In fact, that's the name of the symbol. It says and. So you have to be in set A and in set B. So as you can see that picture, it's just that overlap. Let's do an example really quick right below. Let's say my set is set A is 1, 2, 3. All right, let's set B. We'll say B is, let's say it's 2, 3, and let's go crazy, and 7. Whew. I know, right? Now the intersection of these two would be written as A upside down U or and B. Well, the intersection is what they have in common. What are the numbers that are shared both in A and B? And in this case, we have a 2 in A, and we also have a 2 in B. We also have a 3 in A, and we have a 3 in B. A has a 1, but B doesn't, so they don't share it. 7's in B, but it's not in A, so they don't share that one. So A intersect B, or A and B would just be the set 2, 3. That's their overlap. The next one is a union. When I think of union, I think of putting two things together. I think of a lot of times when they say marriage is a union between two people. And when you get married to someone, you don't just share your overlap or what you share in common, your entire people being added together. So a union is really putting two sets together. So union is what belongs to either set. You're taking set A and set B and pushing them together into one big set. Now the symbol we use for that is a U, and that U stands for or. That U in math, we actually say or in its place. So the statement A or U, B is read A or B. If you notice the Venn diagram, it is everything colored in. And so our example with the sets that we have above, if A is 1, 2, 3, and B is 2, 3, and 7, then A union B is going to be all those sets put together. So we have 1, 2, 3, and 7. That is all the numbers that are in both A, and we also have them in B. So you are adding those two sets together. And we get one bigger set usually. All right, that's the down and dirty of intersection and union. Let's see how that applies to interval notation. So our first one is A union B, or A or B. So I'm looking for all the stuff that's in A and combine it with the stuff that's in B. So the first one I'm going to do, I'm going to graph set A. Well, set A is 1 to 5 using parentheses. So that is my A. My B is 3 to 7. So we'll put that there, and we'll put a parenthesis at 7. And now what we're looking for is A or B. In other words, A union B. So it's everything that's in A, and tack that on to everything that's in B, and write it all down here. So if we kind of picture this all being transferred down to this bottom one, well, A provides me my far left value, so that's 1. A ends at 5, but B picks up at 5 and continues all the way to 7. So when I add these two things together, we get one big set that goes from 1 to 7. For A, it starts at 1 and ends at 7. If there's ever a gap, sometimes you have to put a union on it. All right, let's say this went from 1 to 5 and this went from 7 to 10. You'd have to go 1 through 5 and 7 through 10. So sometimes you have to break that apart. All right, our next one is an intersection. That is A intersects B. So our A and B aren't going to change, so let's redraw those graphs. Our A goes from 1 to 5 with parentheses. Our B goes from 3 to 7 using brackets on 3 and a parenthesis on 7. And so A intersect B is where these two things overlap. And if I look here, they don't quite line up, but you can look at it. It's at 3, and they overlap till 5. They both exist there. Here's the question. So I know it goes from 3 to 5. So let's color that little section in. Now I have to decide if I'm using brackets or parentheses at those given numbers. I'm looking at number 3 right now. Can anyone tell me if I'm going to use a bracket or a parenthesis at 3? Joe.
You're going to use a bracket.
I'm going to use a bracket. Why am I going to use a bracket?
You are going to use a bracket because for A, that number's included,
Mm-hmm.
and for B, that number's in brackets, so that means it's also included.
That's perfect.
Exactly.
You're going to ask yourself, bracket or parenthesis, all you're going to do is say, is it included in both sets? 3 is included in this set because there's a bracket. 3 is obviously included here because it's colored in. All right, can someone besides Joe tell me whether I'm using a bracket or a parenthesis at 5? Bracket or parenthesis at 5? Ahmed. We're using a parenthesis. And we're using a parenthesis because it's not included in A. There is no 5 in A. There's already a parenthesis there. It is in B, but it has to be in both of them. It is not in A, so it has to be a parenthesis here. All right, the last thing is A intersects C. Well, we've been doing with A. A is pretty easy. It just goes from 1 to the old Cinco. C goes from 6 all the way to infinity, and we put a parenthesis at 6. And since it is an intersect, I have to ask myself, where do these overlap? And who can tell me where these actually overlap? Or which numbers are shared between those two sets? Anna?
They don't.
They don't. There's no overlap. There's no overlap. So we can kind of, if I ask for a graph, you just say either no overlap. That says lop. Now it says lap. Or you just do one of these guys that we so like to draw on things. There's no solution. There's no overlap. Make sure you know whether it's intersection or union, though. Because if this was a union, it would have an answer. It would be all of A drawn on here and all of C drawn on there. So just make sure when you draw that circle with a line through it, you ask yourself, wait, real quick, is it a union or an intersection? And I think the easiest way to determine with those letters is that U makes a union, and union to me means put two things together. Where intersection, I'm looking at one little space. Like on streets, I'm looking at that one little corner is the intersection. All right, we have some examples. We're supposed to solve these inequalities. Well, before I even care about and or ors, what I'm going to do is I'm just going to solve both of those linear inequalities, and then I'll worry about that and or. So hopefully I can get my most points out without just saying I can't solve it. At least do what you know how to do. So I have 2x minus 3 is greater than 5. I would add 3 to both sides to get me 2x is greater than 8. Then I would divide both sides by 2 to give me x is bigger than 4. Now let's deal with the other one. I would subtract 4 on both sides to give me negative x is less than or equal to negative 1. I'd multiply both sides by a negative 1 to give me x is less than or equal to a positive 1. I multiplied by a negative 1 on both sides, and I got x is less than or equal to, Patrick.
You have to flip the sign.
Thank you. I have to flip the sign. I need to flip that sign because I'm multiplying by a negative. In fact, maybe I'll put that on there that, I was multiplying by a negative 1. That's why I flipped it. All right, and then we have an and statement. And what I'm kind of picturing in my head, right? So it's an and statement. So what we're thinking about is basically saying, where does this intersect with that? Where is the overlap? And it's not so bad with this one. I'm going to still graph both of them because it's sometimes nice to be able to graph it on a test just to double check. But I'm asking, where do these two things overlap? So if I'm not asking you to graph it, right? On this type of problem, I'm not making you graph it. If you can see the answer, just give me the answer. But if not, we're going to go ahead and graph it. So I'm going to graph x is bigger than 4. So let's put 4 out here. It's bigger than 4, so it'd be a parenthesis, and I'd fill that in. Our next one is x is greater than or equal to 1. So let's put 1 here. Let's go 2, 3, kind of so our 4s match up. It's bigger than or equal to 1, so I'm going to put a bracket at 1, and I'm going to color. Now, like I said, because it's an and statement, it has to be in both of them, which means it's our intersection, which means I'm asking where do they overlap. Ahmed.
So would it be bracket 1, like to infinity then?
Is that where they overlap, though?
Well, like, no.
You are correct if it's an or statement.
It overlaps like at the 4 though, because like.
Yes. Yeah, it overlaps at the 4, right?
Oh, so would you start with the 4 then?
Yeah, 4 would be my lowest one. So if I'm putting my overlap, that would be my A intersects B. That graph is where it overlaps, just like Ahmed said, I have to start at the 4. It's the first thing that they kind of have in common, even though I can't include it because it's up here. But it's the first time we started drawing stuff on both of them. And then I just continue over here. And in interval notation, that would just be 4 to infinity. And it's where they overlap, right? So don't start here just because it does over here. Just make sure that they're shared in both of them. Any questions on that one? Does that kind of make sense and why I draw that graph? Like I said on the test, you don't have to draw this graph, but it's something that's really helpful if you get stuck. All right, our next one is an or statement. So it's a union. I want to graph everything that's in A and add on to that everything that's in my set B. So let's first solve our sets. So our first one, I would subtract 4 from both sides. That'd be negative 3x is less than negative 6. I'm dividing by a negative, so that means I need to flip that sign that Patrick yelled at me for before. So we're going to have x is greater than 2. Our next one, what I'm going to do is, we see this little 3 hanging out here? Rather than distribute it, I'm just going to divide by 3. It doesn't matter. You can distribute it. You get the same answer. We all know how to solve problems. You choose I guess. Okay, I'm going to divide both sides by 3 to give me x minus 2 is less than or equal to a negative 2. Then I would add 2 to both sides, and I have x is less than or equal to 0. And this is an or statement, so we are actually doing a union. It is A union B. So I want to have everything. I want to have everything included in it. I'm going to do a graph. Like I said, you don't have to necessarily have a graph, but I'm going to do my graph of x is greater than 2. That's not too hard to draw because we could just do a 2 here and just draw a picture like this. This is how quick it can be. My other one is x is less than or equal to 0. My hint to you is no matter how quick you're doing this, if I'm using this to compare, I'd put 0 about where I'd have 0 on the other graph, so maybe about there. And we're not including 2, so I'd put a parenthesis. We are including 0, so I'd put a bracket. Well, this is a union. This is A union b. So I'm going to take everything from x is greater than 2 and put it on here. So that looks something like this. I'm also going to take everything from the other one, which would be that 0. That is union, taking everything and pushing it together. Well, rewriting this in interval notation would be negative infinity. That's my lowest value. It stops at 0 with a bracket because we do include it. And we're going to union that with 2 to infinity. So no matter how many segments we have, we just keep unioning them together. So if I had a third section, I would just union that on. Just make sure you go from left to right. Okay, I went from negative infinity, I stopped at 0, put a bracket on it. Then this is my union, got to skip this, 2 to infinity. All right, that very last one is probably the easiest of any of these to do. And realistically, see how it's negative 4 is less than or equal to 3x minus 1? This is actually an and statement, because x has to be true for both these statements. So I'm looking at negative 4 is less than or equal to 3x minus 1, and 3x minus 1 is less than 5. But we don't need to break it apart. We can solve it as is. This is just a 3-sided equation now. It's just like solving a 2-sided, except when you do it on both sides, now you have to do it to all 3 sides. So we're going to try getting x all by itself in this middle. So the first thing you would do is you would add 1 to it. But that means I need to add that to the left side, and I have to add it to the very right side, which is going to give me negative 3 is less than or equal to 3x, that turns to 0, is less than 6. Now I need to divide by 3, which means I'm going to divide everything by 3. That's going to give me a negative 1 is less than or equal to x is less than 2. I probably don't have to graph everything because it really is just one kind of simple graph if I asked you to graph it. And that would be, well, we start at negative 1, 0, 1, 2. Put a parenthesis there. X is somewhere between here. Or in interval notation, it would just be negative 1 to 2 with a bracket around negative 1 and a parenthesis around